Modeling this table. Hi, Joe Cerrone, CAD 136. I'm going to go through and show you how to model this table using AutoCAD. The file is located right here, and so if you download this file and open it, the PDF will look like this. And in this example, what the author has done is he's given us a top, front, and an isometric view of it, but he hasn't put any dimensions on it. And so what he's asked us to do is to scale that 1 inch equals a foot. And so you'll take out your handy dandy architectural scale and record these measurements. I've already done that for you, and I created a student file where I went through and translated those dimensions. And so what we're going to do is we're going to open that student file, and then we're going to extrude the top of the table. We'll extrude that 2 inches, and then we'll revolve the center line of the table here, and then we'll extrude this leg right here, and then we'll array it for the other 2 legs. All right, so let's get started. The file is located right here, student file for the project, and so you can download it. Open the file. Ignore the unresolved reference. If you bring in the image file for the table, you'll see how I translated those dimensions from the drawing. And so what I did was to go through and lay this out in 2D, and if we look at it, you can see that the table is 4 feet in diameter. That's a 2-foot radius. And then if we wanted to check the distance, I'm just going to have to type it in. Table height is approximately 3 feet 6 inches. And so what I've done is I went through and I drew the circle for the top, and then I created an outline of the shape of the outside. These are a little bubbly, but I think we'll leave them. They'll work fine. We have a center line going down the middle, and it just kind of keeps things lined up when we start to model this. And then we have the leg, which I created with a spline. And you want to make sure that all the endpoints are connected or joined. You don't want any gaps, or you don't want any lines that are not endpoint to endpoint. I'm using the 3D workspace here. And so if you're not in a 3D workspace, you can go and switch over to 3D modeling here. I like to turn on the toolbar, the menu bar. If the menu bar is not on, turn that on. And then what we'll do to make this work is we will create a region of this piece right here, because if you revolve something that is not a boundary shape, it will become a wireframe. And I'll show you what I mean. If I go and I grab an isometric view, and then I use the revolve command, and I grab this geometry right here, and let's grab this here, and we revolve it about this center line, you can see it kind of looks like a net or a spider web, and that's a surface. And so if I click on it and I right click and I go to quick properties, it says it's a surface. And we really can't do the same things that we can do with solids. And so solids are much better versus a surface. In order to be able to create something like that, we have to have a boundary shape. The quickest way is to use the boundary command, or let's use the region command. And by creating a region out of this shape right here, we can then create a solid model. I'm going to type WP for window polygon. And window polygon is a really good way to do this, to make sure that you get all the geometry in there. And that looks fine. Enter, enter. And it did not work. The reason it didn't work is because I'm not in a top view. So let me go and switch over to a top view. Let's try that again. Region. create a box around it, and hit enter. You see that the center line changed to a blue line. If I go and change it from wireframe to conceptual, you'll see that. And we're going to also create a region out of the leg shape. Region. Select the geometry and hit enter. And what I did was I modeled this leg and then I moved it over 6 inches. And so what we'll do once we extrude this is we'll move it over 6 inches. We'll also push it down. It's going to be extruded 1 inch thick, and so we'll push it down a 1/2 inch so it stays centered on the cylinder. That's about all we need to do to this geometry before we start to model it. We'll switch over from a top view to a southeast isometric view. We'll zoom in on it. We'll go to the Revolve command, and let's change the color. Something that looks like furniture, something that looks like wood. And then we'll revolve that. We'll select that shape, hit enter, and then define the axis of rotation. And then we can either move the mouse or we can just type in 360. And then we'll extrude this shape right here. And we'll extrude that 1 inch. And then what we'll do is we'll move it in the z-axis. And I'm going to just kind of over push this down, and I'm going to say 0.5. And that way, when we move this over this way, by grabbing this rocket, or the x-axis, 6 inches, it will be centered on the column. Next thing that we're going to do is we're going to orbit this and take a look at it. Shift middle mouse wheel. That looks great. We're not going to union these pieces yet because we have to array them. In the top view here, I'm going to delete that and I'm going to extrude this 2 inches. Since it's a circle, it's already a boundary shape. And we can go up or down. I'm going to go up, or positive Z, 2 inches. And then what I'm going to do is I'm going to put a UCS on the end of this. And what a UCS is, a user coordinate system. It's basically how you control the XY axis. So we're going to put an XY axis on the bottom of this, and then we're going to do a polar array. Before we do, let's just save it, just in case we have any problems. So we'll save as, and then we'll save that with our initials. Project 14-2. And you can get rid of the student file if you like. Okay, so to be able to create a polar array here, I'll show you what happens if you just do it with the XY axis in the world coordinate system. We go here to the array command, polar, and if you hover over it long enough, it'll give you the command. And then if we select the object, end the selection by hitting enter, and if we put the center point of the array here at the center of it, it stays in the XY coordinate system. And most of your commands are in the XY coordinate system, and so you just manipulate or move that XY coordinate system. I'm going to hit escape here and undo that. So to be able to change the XY coordinate system, one method is to use a 3-point UCS. And so we'll say 3-point, and then we'll hover over the center. And I have my O snaps on, and I also have my 3D O snaps on. So to enable those, you can go to O snap, and you want the O snaps on, the 2D ones, and the 3D ones as well. And so with those enabled, you'll see that the glyphs are blue. And what we'll do is we'll say 3-point UCS, we'll hover, acquire, bring it over to the quadrant, click. That's our x-axis, and that's our y-axis. And so now our XY plane is on the bottom, and when we use the array command with the center of the part, everything stays in the correct orientation. And that's a few too many legs for me. We'll say 3 here, and then we'll green check mark it. And then we'll go back to our previous coordinate system, which is the world coordinate system. And you can just hit this world right here, and that's the default. We're going to go back to an isometric view, and then we're going to 3D rotate this. We can union the legs to the table so that they don't come apart. So we'll come up to union, and then we'll select these and hit enter. And it'll give us some feedback that it did that. If you hover, you'll also see that it's done that. This geometry we're not going to need, so I'm just going to erase it. We could have revolved the tabletop as well. I'm going to 3D rotate this with the rotate gizmo. I'm going to choose the red axis, which is the x-axis, and then I'm going to just bring this until it goes 90 degrees. Now you want to be careful not to do it, not to rotate it any less than 90, like 89 degrees. It's got to be perfectly 90. So you want your polar tracking on or your ortho. And we'll hit escape there. We're going to change to a wireframe. And I put a point right in the center of this. We really don't need these other 2 lines. We don't need this here, and we don't need this. This is a point, and what we can do is we can move our table, and we'll include the point from the node. Point is called a node in AutoCAD, to the center. And if we verify that with a conceptual view, that's our table. And I'm not going to union the top on it. You can certainly do that. I think what I might do is 3D print this. Double click in the viewport in paper space, double click on the mouse, and then we can go through and we can create the views for this. We'll go and change that to a southeast isometric. And I'm just going to kind of make that by eye. And then I'm going to put a visual style of conceptual. And if we want to have some fun with this, we can go and create multiple viewports by erasing this and using the viewport command, where we go to viewports, and we can create 3 viewports. And let's just see what it does here. All right, that's what I wanted it to do. So with the 3 viewports created, I want to then set the viewing perspective. I'll double click in this view, and I'll make it a top view. And then I'll line that up. I'll double click in this view, and I'll make it a front view. And then I'll line that up. We don't need the grids, so I'll turn those off. And these really could be transparent, and so the visual style would be best served with wireframe. Remember to put your name on it, and that completes our video for how to model a table.